So here we are on question 3 of paper 1. And when students look at this, they would hopefully recognize this as a modulus question. So it's an algebra question. You know, it is one that would be tipped to come up this year in 2021. So it's well worth knowing. This question, I imagine some students would have chosen to avoid this one when they look through it because it's kind of an abstract question. You know, there's X's and A's in there, and it's a little bit of a kind of a, you know, when you're reading through it, it's not necessarily obvious exactly what's being meant. You have to read through it a couple of times to figure it out. But once you do, it's actually not a difficult question, as is often the case. As x equals 4, or it says x equals 4 is a solution to this equation. The modulus of 3x minus a is equal to half x plus 2. Using substitution, 2 possible values of a can be found. Show that one value of a is 16 and then find the other value. Okay. So as I often say, if you don't know what to do, do what you know. So you're going to start off. You're going to fill in 4 for x because that's what it, you know, we're told it's a solution. So we're putting that in for x. And I get the modulus of 12 minus a is equal to 4. And there's 2 different ways to do this. I can square both sides. 12 minus a to be squared is equal to 4 squared. 144 minus 24a plus a squared is equal to 16. A squared minus 24a plus 144 minus 16 is equal to 0. I'm going to get my quadratic. I'm going to factorize it. I get a is equal to a minus 16 times a minus 8 is equal to 0. 2 things multiplied together equal 0. Either the first is 0 or the second is 0. So I'll have a minus 16 equals 0, giving me a equals 16, or a minus 8 equals 0, a equals to 8. Given the fact that we were told that a equals 16 as one of the solutions, we're very confident we're right. And obviously then a equals 8 is the other solution. Okay, so that was a 10 marker. I'll just point this out, just a quicker way to do this. That when you are back here, you could take what's known as the plus or minus case. So you could say, okay, the modulus of 12 minus a is equal to 4. And you can say, well, that implies that 12 minus a is equal to 4, or 12 minus a is equal to minus 4. And you might ask yourself, well, why does that work? Well, if you said the modulus of x is equal to 4, that implies x is equal to plus or minus 4. Because, you know, if you put in 4 into the modulus of 4 is 4. If you put in minus 4 into the modulus of minus 4 is 4. So both of those will work. And the same logic holds down into this next part. And the beauty of that is then you can solve it. And if you're going to get, solving this one here, you're going to get 8 is equal to a, if you bring a over to the right hand side. And over here, you're going to get 16 is equal to a. And of course, those are the 2 solutions. And you found them much more quickly. So that's called a plus or minus case. Okay, that's how you do that one. Okay, 10 marks either way. Now, here's where you really do need to be looking through it, highlighting it, thinking about this. It says for a equals 16, x equals 4 is the smaller of the 2 solutions. Using this value of a, find the value of the larger solution. So, you know, you might be getting confused here between the different parts, and like obviously that's why it's worded in this way, to make it seem a bit more confusing, to make you work for it. Because in this case, like there was a lower value of a being 8, the higher value of a being 16. But in this case, we're told a is 16. So we're saying it is 16, and x equals 4 is the smaller of the 2 solutions. Using a equals 16, so using a equals 16, find the larger value. So in this case, what I'm going to do again is I'm just going to start this off here. So what I should say is the modulus of 3x minus 16 is equal to half x plus 2. And again, you can take the plus or minus case. So you're saying 3x minus 16 is equal to plus a half x plus 2, or 3x minus 16 is equal to minus a half x, and it'll be plus 2, but that'll become negative in a moment. So if I do this guy here, if I take this guy here on the right hand side, I'm going to get 3x minus 16 is equal to minus a half x minus 2. What am I going to get here? I'm going to get like 3.5x is going to be equal to 14. Divide both sides by the 3.5. I'm going to get x is equal to 4. Okay. And then x equals 4 is corresponding to this one. So it's the smaller of the two values. So that's not the one I'm looking for. But so if I take my plus case, this is the one I'm going to be looking for. I'm going to get 3x minus 16 is equal to a half x plus 2. 3x minus 18 is equal to a half x. Let me work this out here a second. So I'm multiplying across by 2 here. So of course, again, I'm going to get 6x minus 36 is equal to x. I'm going to get 5x is equal to 36. I'm going to divide across. I'm going to get x is equal to 36 over 5. What's that? 5.2. So my answer for that part there is going to be 36 over 5, and that was for 10 marks. So, okay, there was definitely a bit of thinking involved there at the start. But in the end, was it that difficult? I'm going to say not once you get going anywhere. Now, the last part here, again, is something similar. You read through this, sketch the graph of the equation, or with the equation y equals f of x, where f of x is equal to the modulus of 3x minus a and x and m to real numbers, showing the coordinates at a point where the graph cuts or meets the coordinate axes. The coordinates should be given in terms of a. So a particular value of a is not required. So you didn't actually have to solve it. It was a general graph we were looking for here. So all you needed were the coordinates of the points where the graph cuts or meets the coordinate axis. And really what's been looked for here is, do you understand, what these modulus graphs look like? They always have certain things in common. So let me explain. In this case, if you're saying y is equal to the modulus of 3x minus a, well, if x is 0, then you're going to have the following. You're going to have y is equal to the modulus of minus a, but the modulus of minus a will be a. Okay, it will be a positive value a. So therefore, you're going to have a point when x is 0, y will be a. So it'll be the point 0a. When y is 0, then you're going to have 0 is equal to the modulus of 3x minus a. So then 3x minus a is equal to 0, because again, if you take the plus or minus case, in this case, plus or minus, you can have plus or minus 0 is equal to 3x minus a. But of course, it doesn't matter if it's plus or minus 0, it's just going to be 0. So you're going to have 3x is equal to a, x is equal to a over 3. And then what's been found here is, like, do we understand then what this means? So my coordinate, my point is a over 3 comma 0. So here is my graph. Okay, we're over here in the first quadrant. We have the point a over 3 comma 0. Okay, so that's one point where it intersects the x-axis, or where it intersects the y-axis is the point 0a. Just a little typo there. So 0a. Okay, so that's it. Was it that difficult? Probably not as difficult as a lot of students would have thought. I know students will have avoided this question, and hopefully when you look back at it now, you'll have learned something and be ready for the real exam.